Hey Goja. Invalid module. I know that one, believe me. But just real quick, could you load a file? Invalid module. I know, but we're friends and I was just thinking maybe just this one invalid module. Okay, whoa. This might be my last stream. We've spent a few days working on Pocket Pages and updating things in the supporting libraries. Now we're circling back around to Kingdom because I have a goal that in the next 10 days, I will have some kind of paid battle pass, something like that, for Kingdom. Before I do that, I want to make a few upgrades because there are a few things going on in terms of bugs. By the way, I'm splitting up this stream. We're going to do a half hour now and then do a bunch more later. So need to figure out what's different in battle.js here. Health to strength. Oh yeah, I think I was trying to do some kind of upgrade here having to do with health and strength. I haven't touched this for like 5 days, but I vaguely remember something about it needing to broadcast new health. Before we even get into that, there is a feature that I want to add to get rid of cells that have not been touched for, let's say, minutes or something like that. Maybe the only exception being if you are guarding the Bitcoin cell. If you're guarding the golden cell, maybe that and any cells around it, perhaps those survive. But everything else, if you haven't touched it in maybe 5 rounds or something like that, it gets wiped off the board, because what's happening is people are filling up the entire board and then there's no way for a new player to come in. They fill up the board and then they leave and there's no way for a new player to come in. So we need to figure that out. Here's what I'm thinking. First of all, let's see if we can commit a few of these changes. I made a change where we don't go all the way to the edge of the grid cell with the avatars. That's what this change is. I think I will add a change set for this. Let's call it a patch. We'll say enhancement, leave padding around avatar and grid cell border. I had a thought today that these live streams might be better if I stopped saying this and that and it and adjusted my vocabulary to be more descriptive so that if people are just listening to it like I was when I was working out this morning, I was listening to the latest episode and I found that it was hard to listen to it because I was really counting on people being able to see the visuals and I was referencing things generically. So I'm working on eliminating that. So here we're going to stage some changes. I'm adding the change set note and I'm adding the modification from Index.js, the homepage, that adds some styling to give some padding around the avatar so the avatars don't extend all the way to the edge of the grid cell. It makes the game feel just a little less crowded. I'll call that an enhancement and commit the change. And I realize now that I forgot to commit the CSS changes that go along with it. So I will commit app.css as well, undo the commit, stage app.css, and recommit. Now we have a nice clean commit for the avatar padding problem. We have some changes in the battle calculation code where it attempts to rebroadcast the strength hint for each cell if that cell strength changes. I know that there's a bug in that already, but I'm going to commit it as is for now, and we'll come back to it. So this is a bug fix. I don't think we need a change set note for this particular bug fix. I'll just say fix for the commit message, improve health hint real-time deltas. We'll stage the 2 JS files that needed changes to support that, commit that, and then there are only 2 other disparate changes in the working directory. One is that we updated, so we'll add a commit chore, update Pocket Pages to version, I happen to know it's 12.4, stage those files, commit, and then the last chore, I've started a to-do markdown with a to-do list of problems and issues and features that I'm thinking about with Kingdom, and we'll put that in the repo as well. So the commit message is add to-do list. We'll commit the to-do markdown, we'll push all those changes remotely just so that they're stored safely somewhere. And now we have about 15 minutes on this chunk of the stream where we can work on the cell decay feature. I don't have much of a plan for this, but I have a little bit of a concept that I want the cell decay feature to store the last time a cell has been touched and put it on a TTL. And I'm thinking I want it to be touched by the player that owns the cell, not just any player attacking it. But that's an interesting... If the cell is active in the game, maybe it's better to measure the TTL by the last interaction time. But that still allows players to tie up the grid, potentially by teaming back and forth. The other way to solve this is to simply make the grid bigger. I've noticed that people have been signing up for the 7-day trial and immediately canceling the 7-day trial so that their sub just times out on PocketHost. I'm thinking of eliminating the 7-day trial. I do the same thing. I'll sign up for the $2.99 Paramount trial for 30 days and I'll immediately cancel it and keep watching for the 30 days and just take the deal. But I don't know. Is any of this going to make or break PocketHost? We're an order of magnitude off from what I would consider viability with PocketHost. So not sure that people canceling their 7-day trials is really going to change the game. So let's think for a moment. I could make this an infinite grid where you can scroll around and continue finding new land. This is kind of how Clash of Clans solved this, right? Everybody gets their own little fiefdom and then you go raid each other's. And in this sense, they allowed for unlimited games, whereas Kingdom is real-time multiplayer on one grid and the grid gets crowded. For now, I think I want to keep the grid a fixed size. It could be fun someday to introduce grid wars where you lay one grid over another and battle for supremacy somehow. Let's make a decision and ship something. So I'm going back into global DTS, which is where I keep all of the types, the data types that I'm using for Kingdom. It doesn't use this directly because I'm not programming Kingdom in TypeScript. PocketPages doesn't support TypeScript yet, but having these data types defined does help with code completion and AI assistance. So there is something in the global types called cell state, and cell state has a player ID, player health, player strength, which is a hint about how much health they have, and an array to say who is currently attacking that cell, which other cells are currently attacking that cell. We want a fifth field in here. I'll just name it TTL, and it's a number. During the battle phase, if the TTL on a cell expires, that cell will be destroyed. We have a function in Battle.js called calculate war results, and calculate war results is called every time the game state changes into the battle phase. The first thing it does is iterate through the grid cells to figure out who is attacking who. Yeah, okay, I'm back. So we're looking at the room battle deltas, and I'm checking out how this battle code works. It will set the player ID to null if that cell is destroyed. Then the algorithm applies all of those deltas to the room, and then it updates the strength of the cells. Right, so I see a prerequisite change that I would like to make first. I see some errors in how the health and strength are reported in the deltas. And I'm not sure if it's listed in our to-do markdown, but we also want to adjust the game by making it so if the attacking player loses against the defending player doesn't automatically get the attacking player's cell. That cell just becomes empty instead. So I'm going to add to the to-do here, enhancement, defending players do not get attacker's cell even if they win. And then I have a note in here about a general bug, don't broadcast unchanged deltas. We'll come back to that. So for now I need to stop the stream and we'll come back to everything. We're back and looking at some Flounder t-shirt designs coming from Oakdag. He's talking about the back of the shirt and AI made a cruise ship for him. That's funny, always shipping. I like some of these, man. I actually kind of like that ship wheel as maybe the good logo for PocketHost. See, but Oakdag made these here, which I like. And I told him that he's gone farther than anybody else with the t-shirt designs. So, we'll open source the t-shirt designs and maybe these will be version 1. I'm going to tell him I like the steering wheel. Maybe even as a new logo for PocketHost. Let's jump back in our Kingdom to-do list here. We were looking at adjusting the code so that defending players do not get the attacker's cell even if they win. So let me study through this and figure out how that would work. My whole family just tested positive for COVID. All right, I think the first thing I want to do for clarity is instead of calling these player 1 and player 2, I'm going to call it attacker and defender everywhere in here. So let's try refactoring this battle algorithm to refer to attackers and defenders. So we iterate through the grid cells, and for each cell we have, instead of the player 2 index of the cell, we're going to call this the defender index. And Cloud already understands what I'm doing because inside this loop, the array of attacked by indices, instead of calling those player 1 index, Cloud understands that those are the attacker index. So the attacks are now an array of where the first element in the pair is the attacker index and the second element is the defender index. Let's see where I should make the next change. Here we iterate through all the attacks and we destructure each attack into P1 index and P2 index, which we now know are attacker index and defender index. So I'm going to use the Visual Studio or the cursor rename symbol instead of letting Cloud do it, because that'll take a lot of tabbing and sometimes Cloud doesn't quite rename everything correctly. I'm just going to do it here and use cursor's syntax tree parsing to replace this symbol. Attacker index is the first element and it replaced it everywhere. And then I'll rename the P2 index to defender index and that replaced it everywhere else in the loop. Then as I scroll down, I see we reference P1 cell, P2 cell, P1 ID, P2 ID. These are all going to be changed to attacker and defender. And scrolling down even more in the battle calculations, we have P1 and P2, which are the player models. So we're going to rename these. Instead of P1 and P2, it will be attacker and defender. And by using the rename feature instead of letting Cloud do it, I feel that we are doing a syntactically deterministic replacement function instead of relying on AI, which can be kind of fuzzy at times. So there are times where AI is useful, and then there are times where I think a more traditional approach to programming is better. We're looking now at the damage calculations to see if those change. So the damage done is the minimum of the attacker's health or the defender's health. They both sustain the damage equal to the lesser of the two of them. That doesn't change. The outcome might change. Right now, the outcome is -1 if the attacker prevails, 0 if they both lose, and 1 if the defender prevails. I think we can leave the outcome the way it is. Scrolling down to the cell health and player health calculations, these I believe will change, but instead of P1 health, P2 health, C1 health, C2 health, I'm going to rename these. So P1 health becomes attacker health, P2 health becomes defender health, C1 health becomes attacker cell health, and C2 health becomes defender cell health. Now the next piece of logic in the battle calculation, actually I see now that I can simplify the outcome of the battle to just be defender cell health minus attacker cell health. If they are equal, the outcome will be 0. If the attacker has superior power, the outcome will be negative, meaning in favor of the attacker. And if the defender has superior power, the outcome will be positive, meaning in favor of the defender. So the attacker's health is the current attacker's health minus the damage, plus if the attacker wins, they take the other cell and therefore gain a point. So the overall health of the attacker goes down by the amount of damage, but if they won the battle, they gain that extra cell with 1 point in that cell. So that logic stays correct. Now the defender health is the current defender's health minus the damage as well, and they now do not get a bonus even if they win, because defenders do not get to capture the attacker's cell. So we're going to remove the bit of logic in the defender health calculation that would add a point to their overall health from that cell that they would gain, because they don't gain that anymore. Now the health of the cell, of the attacker's cell, is the cell health minus the damage, or null, meaning if the cell health is 0, the health goes to a null value instead because the attacker is no longer occupying that cell, so the health of that cell goes to null. The defender cell health is the current cell health minus the damage, which could take it down to 0. Plus, if the attacker won, that cell health will change to a 1. Otherwise, it will change to a 0. And if it's 0, the whole thing will change to null. That actually seems very convoluted to me, but it is logically correct. Then, if the attacker won, the defender's cell is protected for the rest of the battle because there's been a victory in that cell. Nobody else can touch it, even if they had planned to attack it from a different position. Somebody has already conquered it, and that's it for the battle. So that logic stays. If the outcome is that the defender won, then the attacker has been vanquished, and therefore the attacker cell is protected. And then in both cases, if the outcome is a tie, it means they destroyed each other, in which case both cells are protected. So that part is still good. Now we get into the deltas. So what has potentially changed in the course of these attacks? The health of the attacking and defending cells and the attacking and defending players has changed. That stays the same. In terms of public information, the player ID of the attacking cell is either the attacker ID or nothing at all. There's no case where the defender gets that cell anymore. And then the strength of the attacker cell, the strength hint, is the health to strength of the attacker cell health. Otherwise, the strength is 0. That makes sense. Now, the defender index. If the attacker has won, the player ID of the defending cell becomes the attacker ID. If the defender won, it stays as the defender ID. If they tied, the defender cell become null. It's empty. Strength of the defending cell. If the defender won, it is the new strength of the defending cell's health. If the attacker won, we know the cell just has 1 point in it, so we'll do health to strength of 1. Otherwise, the strength is 0. That's the public information. What does the attacker need to know? Right, so public information. This is what everybody gets to know about the cells. If the attacker won the battle, the attacker cell player ID remains the same. Otherwise, it changes to null. If the attacker won the battle, the attacking cell's strength is updated to the new attacking cell health. Otherwise, it's set to 0. That's fine. That's public information as well. If the defender lost, the defending cell's player ID becomes owned by the attacker ID. If the defender won, it stays as the defender ID. Otherwise, it is empty if they tied. That's correct. And the strength of the defending index is the defending cell's index if the defender won. Otherwise, it's a strength of 1 health because the attacker occupies it now, or it's 0 strength in the event of a tie. So that public information is correct. The delta that gets sent privately to the attacker, what do they need to know that hasn't already been sent publicly? They need to know their own new health, and they need to know the attacking and defending cell's health, but only if they owned those cells. So I'm going to make that a conditional down here. After the main delta structure has been calculated, we'll say if outcome less than 0, then we want to add, well, let's think more carefully about this. Certainly, the attacker's overall health needs to be updated. Now, when does the attacking cell's health need to be updated, and to what? If the attacker won, it becomes the attacker's cell health. Otherwise, the attacker either lost or tied, in which case that cell's health becomes null. If the attacker won against the defender, then the defending cell's health is 1. Otherwise, it's null, meaning the attacker doesn't get to know the health. because they don't own it. That's fine. Now let's look at the defender. In the case of the attacking cell, the defender never gets to know anything about the attacking cell. If the defender won, the defender's cell health is communicated. Otherwise, that cell's health is set to null for the defender. Okay, fair enough. This is where I'm starting to wonder if Immer could help me, because Immer has patches. Tracking the state changes of each cell is becoming complicated, and mirroring those out as deltas is becoming complicated. So I'm curious what the patch format is, because see, if we delivered this patch format, Immer could apply it on the front end as well. Let's see how this calculate function simplifies if we actually were able to use Immer. So we still compute all the attacks, and we still loop through all the attacks, and we still have battles. And if the cell is protected, we still don't do anything. And if for some strange reason there's not an attacker or a defender in the cells, we skip that battle as well. But actually, all of this logic inside the loop that evaluates each should be inside produce with patches. And I'm guessing I want to hoist as much out of the produce with patches as I can, if it affects whether we need to call produce with patches at all, just for efficiency. Cloud is refactoring a lot of this for us pretty effectively. This is nice, this is helpful. I'm gonna help Cloud out a little bit though. So if the outcome is less than 0, meaning the attacker wins, then a bunch of stuff happens. The defender's player ID becomes the attacker player ID. The attacker's strength is recalculated. Okay, I did a little refactoring inside the patch producer because the dereferencing was getting a little convoluted for me to read. So it's better now. And here's what we know so far. We calculate the damage. The attacker cell, the attacker player, the defender cell, and the defending player all take the same damage. Now, if the attacker wins, the defender cell's player ID becomes the attacker player ID, and the defender's cell becomes a health of 1. I would like to know if Immer has a playground. I need to get comfortable here. CJS. All right, well, I tried to get an Immer sandbox set up, and that was damn near impossible. So I'll just test it live here. I was curious to know what happens if you make 2 changes to a draft value. Does that appear as 2 patches or just 1? And I suppose I could answer my question by looking in the Immer source code. I still can't tell, so I'm just gonna go for it. If the attacker wins, the defender cell's player ID becomes the attacker's player ID, and the health becomes 1. And that means the attacker health increments by 1 as well. Then the attacker cell strength is based on the attacker cell's health. The defender cell's strength is now a 0, which I think we could make a little more maintainable by saying that the defender cell's strength is a health to strength of 1. Let's think, is there anything else that changes there? No, I don't think so. If the outcome equals 0, meaning they tied, then it's very easy. The grid attacker index becomes empty, and the grid defender index also becomes empty. If the defender wins, the attacker cell becomes empty, and the defender cells gets updated. So I think we can be a little efficient like this. After we know whether or not the attacker wins, we know the cell strengths remaining. At that point, we can calculate, we know the cell healths. We know the health of both cells. So then we can calculate the strength of both cells. Now, if the defender won, the attacker cell just gets completely erased. And I don't know if Immer is going to like that or not. Update patterns in Immer. Mutations, nested data structures. It looks like you can indeed delete, and that will work. Good, just looking up Immer, it looks that way. All right, so the logic here then is that if the defender wins, we simply delete the attacker's cell altogether. There's nothing left in it. It's a totally empty cell. Well, unless it's got a prize in it, right? I don't think I'm going to worry about that. I think the golden square can vanish again and become hidden again. All right, what happens if I run this locally? One area that I'd like to improve in PocketHost is it's not so easy to sync migrations. Yeah, you see all of those migrations there, TB migration. We've got up to 855, but we don't have any of them after that. So we need to pull over all those migrations manually. I'd like to have a better way of doing that, but now we should be able to run this locally, which, by the way, we're on PocketBased 23.4. What happens if I do PocketBased update? Cross-device link. Well, guys, I'm finding a problem with the require statements and that they are not overridden the way I thought they were in the Goja JSVM. So that's as far as I'm going to get tonight. I'm going to stop the stream and check in with you guys later.